Good noon.
Happy day, right? Hope everybody's graduation ceremonies are going well. Today we have Martin Smith with the SDVoE Alliance. So Martin's going to be talking to us about SDVoE. Atlona has some new products that just came out, a new 8x8 switcher, and we got a new one coming out after this one that are SDVoE based. So I invited Martin to join this group to kind of give us another different perspective on the AV over IP discussion we've been having. So with that, Martin, take it away.
Okay, thank you. Really happy to be here. First time with this group, so super excited about it. Normally, I would be wearing my SDVoE shirt. I thought I would wear my University of Colorado Buffaloes hoodie just because that might be fun. So I'm in Colorado. I'm in Fort Collins, Colorado right now, which is actually where the CSU Rams reside. So I'm in enemy territory, but of course we're all friends. So I appreciate the forum, really appreciate the invite from Matt Lona, and I want to go through a deck that I have. I'm going to go through it pretty fast, and we'll have plenty of time for questions at the end. So it's basically two things. What is SDVoE, and how does it compare to other things that are out there? So I'm going to attempt to share my screen. Share screen. And I need to hit another button.
Yeah, there's a confirmation hidden somewhere. Now it's coming through though.
There we go. Okay, so I'm not in slideshow mode, but can you see my screen?
Got it. Yes, sir.
Okay, and now we're
Yep.
with gas here. Okay,
As it should.
excellent. All right, so I'll talk a little about what is SDVoE, and this presentation was actually put together by our CTO, a guy named Stéphane Tremblay, and so there's some interesting phrasing in here, like when AV over IP has been introduced. Okay, his primary language, first language is French, second language is English. So I thought I could go correct all that, but it's fine. So Stéphane said, look, we're all using ChatGPT. What are people seeing when they look at AV over IP? The point here is that AV over IP started to evolve in the early 2000s. The IP networks were not really originally designed for continuous video and audio traffic. So it had to evolve, and the SDVoE standard came along. Some very smart people like Stéphane came along and said, what if we could make standard IP networks work for video? And so SDVoE was defined or really created in 2017. We're kind of the original, the incumbent AV over IP codec. So what does SDVoE mean? Software defined video over Ethernet. So the idea is that we're going to just face the reality that hardware is going to become commoditized as opposed to the way things were done before. So in the old days, and it still exists today, and we'll talk about this more, the matrix switch. So an esoteric, expensive thing from a particular handful of manufacturers that these products were available to route audiovisual signals from various sources to various sinks or displays. And so the idea is, well, why don't we use existing IP infrastructure for this? Wouldn't that make more sense? And of course, there's an entire world of equipment out there. Think Huawei, Cisco, but then now in AV, there are companies like Netgear that are focusing specifically on the AV market. But these are standard Ethernet switches. So SDVoE Alliance is a nonprofit consortium of technology providers collaborating to standardize the adoption of Ethernet to transport AV. And so what this means is a technology shift is underway. We talked about kind of the evolution of AV over IP. And what it does is we deliver the matrix switch without the matrix switch, or matrix switching without the matrix switch, right? Using a standard IP switch to do this, any input to any output type of switching. And of course, why would we do this? Well, AV over IP is more cost effective than other technologies that are out there. And so if we look at a traditional 8x8 matrix switch, and by the way, I have to stop here a little bit. The Atlona product is kind of the best of both worlds. And this isn't an Atlona product pitch by any means, but Steve brought it up, and so they've got a product they introduced with we're just kind of marrying the matrix switch to SDVoE. I'm not speaking to that specifically in this pitch, but they've got a pretty interesting implementation of SDVoE. But the idea here is, look, instead of I'll just go ahead and say it, Crestron, Extron, Harman, matrix switch, let's just use a standard Ethernet switch to accomplish the same thing. AV over IP is more flexible than your traditional matrix switch, being software defined. And what that means is a manufacturer can come along, create an SDVoE product, and then add their own special sauce in software to define, the specific application that they want to create, whether that's just your standard AV over IP, which we're showing here, and we'll talk about other applications like display walls, multiviewers, and KVMs. You can see in the block diagram here, your traditional matrix switch on the left versus the AV over IP architecture on the right is a reduction in number of components. It's a simplified architecture and allows for a great number of applications. So AV over IP is still kind of the Wild West. Every manufacturer, I shouldn't say every, but most manufacturers out there that are making black boxes, media converters, things like that, they say, hey, we need to have an AV over IP solution. So they make their own. And most of the stuff that's out there, except for SDVoE, is 1 gig. And so they rely on heavy compression, and that introduces artifacts and latency, which I'll show in detail in the next few slides. The other thing is that the reality of most AV over IP out there is that it's a walled garden, right? You buy one manufacturer's product, and it's not going to talk to any other manufacturer's product. And so we'll talk about interop here in a bit. And so that's one thing that's important to note about SDVoE. It is 100% a 10 gig standard. It does not operate at 1 gig or any other bandwidth. SDVoE by definition is a 10 gig standard. So why go down a 10 gig path with SDVoE? We'll go through performance, features, verticals, and position versus other AV over IP, which is where it kind of gets interesting. So SDVoE is the only technology that was truly aimed at replacing the matrix switch in terms of performance. Your traditional Crestron, Extron matrix switch is very high performance and also very big price tag. SDVoE meets and or exceeds the performance of a true matrix switch, but operates on a traditional IT network. We'll get to the power of 10 in a later slide, but some of the key benefits of SDVoE are no latency. And some people might point out, well, there's no such thing as zero latency or no latency. Okay, true. But we're talking about microseconds, or here 0.1 millisecond, or in the microsecond range, as opposed to other things that are out there, which are in the orders of magnitude slower in the milliseconds. So in practical terms, no latency. And in practical terms, no compression. And we'll get a little bit more into that moving forward. So what we often show at trade shows is a codec shootout. And what we have here in this block diagram are 3 different devices, SDVoE, A-Speed, which is a 1 gig chip for AV over IP, and then an NVX product, which is Crestron. And we've been showing this shootout up until recently at all of our trade shows. What you're seeing here on the very top part of the block diagram is the reference channel, not going through a switch. And then because SDVoE is based on an ASIC, and by the way, every SDVoE device out there uses a common ASIC from Semtech. I'm actually a Semtech employee, and everybody that wears an SDVoE badge works for one of our alliance companies. And we can talk about the alliance at the end. Who are the players in the alliance? But of course, that Bona is top of mind at the moment. So what we have here is an SDVoE receiver, very low power consumption because it's an ASIC, as is A-Speed. But then you look at the latency of SDVoE, very small compared to the others. And of course, when we compare this to the FPGA-based Crestron solution, you get a huge power increase. One thing that we're able to show in a case study with the European Parliament, they had about 10,000 endpoints, which is obviously a huge install. But that translates directly into a big power savings. It's a very much more green solution to use an ASIC and it's saving them, depending on the price of electricity on any given year, $25,000 to $40,000 a year deploying an SDVoE system versus a FPGA-based system. This picture doesn't really do it justice. When you're standing at our live demo at a show, you can really see the difference. The two images here at the bottom are SDVoE and the reference image. In the blue, well, okay, I'm a little colorblind. I think that's blue, maybe it's purple. That box in the upper right of each screen, you don't see this kind of artifacts and banding that you see in the 1 gig solution from ASpeed and Crestron. And this is just a closer up look at a SDVoE at 10 gig versus a 1 gig solution. It's really, again, these pictures don't quite do it justice. It really helps if you see it live, but suffice to say, you don't get the artifacts that you get in a 1 gig solution when you're using 10 times the bandwidth. So side-by-side codec results of these three, SDVoE versus ASpeed versus Crestron NBX. Only SDVoE does not have visible compression artifacts. You can genlock the video immediately due to the low latency, and we have the lowest power consumption. Now, feature set of SDVoE, what's that about? This is actually really cool. So when we think about HDMI extension, the most popular HDMI extension out there is HDBaseT. It's been around for quite a while. They have, of course, newer versions. What's really cool about SDVoE, it's the only technology out there that you can use in point-to-point mode and will also work in network mode. If you take an SDVoE transmitter and an SDVoE receiver and connect them together, they will automatically recognize each other and go into point-to-point mode. The other thing about SDVoE in point-to-point mode, it's much more robust in terms of EMI interference. We have a video out there called the barbecue lighter test, where if you take a standard big barbecue lighter where you click it, it makes a big EMI pulse that will actually disrupt HDBaseT signals. And you also need to use shielded category cable with HDBaseT, and SDVoE's you don't. So most people don't think about SDVoE in terms of point-to-point, but we're winning more and more business out there because of the superior nature of the technology and point-to-point as well as AV over IP. This is just kind of the standard configuration of AV over IP, but it's not just a cross-point. Essentially, typical cross-point, any source to any sink, but built in to SDVoE is the ability to do video walls and multi-view. So video wall, you take multiple sources and put them into a large wall. You see these in shopping areas and casinos and things like that. Multi-view, kind of the opposite of that, taking multiple sources and putting them on a single display. This functionality, as well as KVM, which stands for keyboard video mouse. I don't probably want to go into a huge description of KVM, but there's a market need out there in secure environments, whether it's military or financial or possibly in education. If you have a really secure location, you don't want somebody walking in with a thumb drive and being able to plug it into the PC. The PC's locked in a closet somewhere, but you still want that user to have the ability to access their own PC. So that's a keyboard, KVM, keyboard video mouse, using that PC from a remote location. All that's built in to the SDVoE chip. This is just a little bit deeper dive on multi-viewer and how that works. Full video composting engine for custom layouts, multiple video sources with a single receiver. You can see on the right side of the screen just the different configurations that you can easily do, whether it's arbitrary, side-by-side, picture-in-a-picture, quad split, other shapes, etc. All that functionality is built in. Here's a little bit more about KVM, point-to-point, or power user, where one user is using multiple PCs, or collaboration, where multiple people are using the same PC. These are all different derivations of KVM. Okay, this is kind of a sidestep. I inserted these slides into this presentation because we'll talk about a few things and there may be questions. Well, how does your API work and things like that. The SDVoE Academy and I'll send links at the end. SDVoE.org is our webpage. Again, it's a nonprofit consortium of technology providers. SDVoE Academy is linked to that. Just click on the Academy link. You can access over 200 free courses. It's basically the convergence of AV and IT. It's not salesy. It's just very much factual and to the point about the convergence of AV and IT. Some of it's pretty deep, but some of it's pretty very high level. What is an API? How does a matrix switch work? So these classes are available, of course, 24/7. We have over 5,000 students. That needs to be updated. It's more now. It's bite-sized pieces of information available in different languages, available in Android and iOS. There's a subset of classes called Certified Design Partner, and this is really for integrators or like the folks in ETC that are developing systems. This is a free CTS credit course. There are 8 classes in this subset, and once you complete them, you take a test and you become an SDVoE Certified Design Partner. This is available in 4 languages. We have over 3,300 people in the world that are SDVoE Certified Design Partners. Again, just how do I design SDVoE systems? And there's just a wealth of information here on how to do that. Okay, the SDVoE API. This is the center of our interoperability. And so remember, not just the API, but the common ASIC. So every SDVoE device out there uses the same ASIC and the same API. And so what this does, it allows for true proven interoperability. We'll talk about some other ways of doing things in a couple slides down the road here, but only SDVoE has proven interoperability. And we're going to be showing at the InfoComm show in 2 weeks an interop demo with 4 different SDVoE Alliance members and a Netgear switch, how these products all work together interoperably. Now, every feature on every box isn't going to necessarily match up with every other manufacturer's product, but they will pass video and communicate with each other. And perhaps more importantly, sorry, I'm forgetting the words, a system that monitors and maintains an AV system remotely can look at all these devices the same way because they all have the same API. And so big integrators like AVI SPL, they have a system called Symphony. As an example, all the big integrators do. So you can use their Symphony remote monitoring platform to monitor and remediate issues instead of rolling a truck or running out to a certain building to fix a problem. SDVoE has some security features built in. The claim feature is again outlined in the SDVoE Academy and how it works. It basically just allows you to segment your SDVoE network, allocating different API servers to groups of endpoints, and that's used to prevent some unknown or unauthorized rogue API from taking access of your endpoints. More about security. What is built into the SDVoE ASIC is USB HID. And if manufacturers want to add a USB 2 functionality beyond USB HID, they can use an additional chip in parallel with the SDVoE chip to deliver camera things that need USB 2.0. So we used to have, for the traditional positioning of SDVoE since 2017, was sustainable, flexible, available. We talked about sustainability, available. We didn't suffer at all during the big parts shortage that happened a couple of years ago. And flexible, we talked about the API. Well, we got together with our Alliance members and we said, wow, there's a lot more than just sustainable, flexible, available. And there are a bunch of reasons why you'd want to use SDVoE. And so we decided to call it the power of 10. There are 10 things, and it's also 10 gig. So it's a little catchy kind of play on 10 gig. We're not going to go through every single one of these in super big detail. Let's see what's on this one. Zero latency. Again, sub-millisecond or microsecond latency, no compression. And you might be saying, well, wait a minute, how do you get 18 gig on 9 gigs of bandwidth? So in practical terms, it's no compression. There's actually a very light compression, a 1.3 to 1 compression engine that is built into SDVoE. In practical terms, it's our customers and our customers' customers generally call it uncompressed. The ability to do video and multi-view video while built in, KVM, we talked about. Insta-switch, so instantaneous transitions when you're switching sources and syncs. It's amazing how quick it is compared to the other technologies out there. No compromise USB 2.0 plus video, we just talked about that. Ultra low power, that's because it's an ASIC, and proven interop. It's a very flexible platform, and we talked about the API standard software interface. And bonus bandwidth. We talked about getting that 4K 6444 over 9 gig. That leaves 1 gig extra for other data for manufacturers to implement. So SDVoE is used in every Pro AV vertical out there. One of our earlier larger customers and a member of the Alliance Savant, big in residential. We've got command and control case studies out there, corporate. I'm not going to go through all of these, but the idea is these powers of 10 are color-coded on the left, and each vertical needs some number of these powers of 10. Education, of course. I thought, well, let's just talk about education. Sorry, I might have to bounce slides here. Okay. What is important? And I don't want to tell you what's important to you, but we have customers that have done deployments in education where zero latency, no compression, fast switching, proven interoperability, and a standard API were very important. We've got tons of case studies on SDVoE.org under technology, I think. This university, not actually heard of it. 10 buildings, over 300 various rooms connect with multiple displays, 900 endpoints. So that's another one of those big deployments, kind of like the European Parliament, where you can see a real cost savings with sustainability in addition to these other benefits. Esports. Again, I don't know each of your business, but we are hearing that esports is becoming a bigger deal on higher education campuses. And so we play really well here because of our no latency, no compromise USB 2.0, proven interoperability, and the standard API. It makes it easy to deploy esports systems. And so we've got another case study here. Carolina's competitive esports team for Rocket League. They've deployed an SDVoE system, and again, we have a case study on SDVoE.org that goes into more detail. I threw this one in because I thought, well, you might have live events on a university application where zero latency, you'd hate to see on a screen that lip sync that's not quite right. I was at a high school graduation just last weekend, and the latency was really annoying. You're looking at the big screen, and then you're looking at the person listening to the audio, and it's not synced. And so zero latency on a big screen like that, you'd want no compression, the ability to do video with multi-walls, fast switching, and on and on. Lots of benefits in the power of 10 that translate well to live events. So where does SDVoE win? SDVoE wins whenever video quality is important. There's no other AV over IP out there that even comes close in terms of video quality. Where low latency is important, no other competitors even come close. No one gets down into the microsecond range. Where multi-view is important, where KVM is important, interoperability. Again, in the next couple of slides, we'll compare SDVoE to a couple of others in terms of interoperability. No one else out there has a common ASIC. No one else out there has a common API like SDVoE. Where true bidirectional video transmission is needed, we have the ability to do a full transceiver, or where we're transporting more than just video is required. That extra 1 gig is helpful. Okay, and so now this is what everybody wants to know. Well, how does SDVoE compare against this or that? So this is kind of our battle card, if you will, versus other codecs and ways of doing SDVoE. So IPMX, this is one that's on everybody's mind. There's so much noise out there about IPMX. IPMX comes out of the broadcast industry. Essentially, it is a group of people that invested heavily in SMPTE SD2110. They're looking to recoup their investment in the AV industry. So they've come up with IPMX as a way to do that. But only SDVoE is completely focused on Pro AV. It's not a broadcast standard, it's a Pro AV standard. Full stack interoperability. Again, you can say anything, and there's a lot of marketing noise out there about IPMX being interoperable. Well, there are 4 different codecs and multiple speeds, and so by definition, it will never be interoperable. And unless something radically changes, it will always be an FPGA-based solution. So only SDVoE is truly interoperable, proven interoperability. Again, we're going to be filming our interoperability at InfoComm in a few weeks, and we'll publish that stuff and have it on social media where you can look at it even if you're not at the show. A large number of available products. We have over 364 products out there. IPMX is up to about 7. I talked to somebody today, one of our ODMs, they're going to be introducing another one, so call it 8. But it's just not even in the same ballpark as the infrastructure that's out there for SDVoE. Low power, again, by definition, it's possible somebody could get behind an IPMX ASIC and spend $15 million on it. With the volume of products out there that are now, it's not realistic. High mean time between failure, again, because of the ASIC. We can work with off-the-shelf Ethernet switches without PTP support. On and on. So there are advantages of SDVoE significant over IPMX. Versus Dante. Okay, so Dante, everyone loves Dante audio. The V story is not as compelling as the AV story. So they have already 4 incompatible profiles. So again, the interop story is out the window. High compression, it's a 1 gig standard. Doesn't touch 10 gig in terms of quality. We have still much superior latency, lower cost ASIC, no royalty fees, integrated wall mode and video mode. So those are the advantages of SDVoE over Dante video. NDI, so NDI is interesting. Again, people say all kinds of things in their marketing, like uncompressed. The reality is, if you look at some of their more popular frame rates and combinations of bandwidth that are out there that they use, we're talking about megabits per second. And this is how they accomplish the certain aspect ratios and data that they're doing. And so, we're talking about megabits, not gigabits, and certainly nowhere near 10 gigabit. It is heavily compressed, even though they might use words in their marketing like uncompressed. It's a very widely adopted standard because it's free. There are lots of products out there that can use NDI. I tried it myself on my Surface Pro and my camera. It's actually really cool. It's super slick, super easy to use. I was able to install NDI on my phone and my PC, and in 2 seconds, I'm looking at the video on my PC that I'm showing on my phone. So it's really cool. It's not in the same ballpark as SDVoE for quality of video transmission. And of course, SDVoE versus ASpeed. You may not know ASpeed, but just anybody's out there that has a 1 gig AV over IP product, it's ASpeed. That's the chip at the heart of it. The Semtech chip is the heart of SDVoE. Semtech is a American semiconductor company out of California. ASpeed is a company out of Taiwan. They're a 1 gig standard. It's just, I can go into details, but just 10 versus 1. Okay, I mean that's the big difference. And SDVoE versus Crestron NVX. So again, comparing to a 1 gig standard, they use mid to high level of compression. Their video quality is good. Sorry if you're hearing a train, I apologize. I have a train track behind my office. We have superior latency, lower power platform, ASIC versus FPGA. A completely open and interoperable ecosystem. I mean, Crestron doesn't work with anything but Crestron, and that's just the reality. I'll talk about a high MTBF in another slide here. We're doing really well on time. And then SDVoE, sorry, versus HD-based-T. We talked about the cable extension performance in the point-to-point application. HD-based-T, even the newest chip, highly susceptible to EMI. Again, you have to use shielded category cable. I worked at Liberty AV for 4 years before this job, and I don't know if you know Liberty, it's all about cable, right? They sell cable, cable, cable. And I learned more about category cable than I ever wanted to know. But they have videos out there saying, hey, if you're going to use HD-based-T, you must use shielded category cable. That's not the case with SDVoE. Let's see, integrated image scaling is built into SDVoE, not so much with HD-based-T is basically as a point-to-point technology. I mean, it's not an AV over IP technology at its core. What people do is they build a matrix switch and they use HD-based-T for the extension portion of their product, but it's not truly doing anything with switching or AV over IP. SDVoE can operate at full 10 gig bandwidth in both directions simultaneously. HD-based-T can't do that, and we're very friendly to fiber, and so you'll see a lot of fiber products out there for SDVoE, whereas HD-based-T is strictly a category cable product. Cable performance, again, we're just showing at a trade show, the superior performance of our AVP 2000T, which is SDVoE, no errors versus a HD-based-T product, and this is a 90-meter shielded category cable, which is what they recommend, but we still are showing some errors, but not in SDVoE. Here's the barbecue ladder test. So if you can see in Stefan's hand here, where this actually. So it's a really quick video, but you can see him click the barbecue lighter, and that EMI, causes this to shut down. Oh, it actually didn't shut down, but you can see the interference in the screen. And I gotta move this here. So I'm having trouble with there we go. And here's another one. And, oh, that's the SDVoE. Okay, so you compare the HD-based-T to SDVoE, you don't get that kind of interference. And of course, finally, we're very similar in power. This is source device quantum data 780E. It's just going through the demo and how that was done. So anyway, not to get into too many details, but you could replicate this setup with this equipment and see how it works exactly as we demonstrated. Here's the other one, BOM complexity. So it was really interesting. This is showing a VS3000, and I believe this is a Crestron card using HD-based-T. Back during the part shortage, Crestron came out very publicly and did a press release and said, hey, we have so many parts on our board, it's hard to get them all, and it's not really our fault. So that's why we can't deliver. The SDVoE architecture is much more simplified, doesn't need nearly as many component products to do the similar function. And so it's a cheaper, cleaner, and more available way to accomplish something. Summary versus HD-based-T. Power is comparable. Cable performance, easy win for SDVoE. EMI robustness, easy win. BOM complexity, easy to medium comparable. So I guess that wasn't a Crestron board. Advanced processing, HD-based-T does not have that, and they are not very easy to use with fiber. So SDVoE wins on almost all points. We're getting to the end of the presentation here. SDVoE versus competitive technologies. I'm more than happy to share this so you can kind of use it as an easy reference. Only SDVoE offers AV over IP, which HD-based-T doesn't. Superior distance over Cat6a cable, unshielded, uncompressed quality, etc. All the way down the list. SDVoE really offers a superior look at point-to-point extension as well as AV over IP. And I probably finished a little bit early. I don't suppose there'll be too many complaints about that. And so we have plenty of time for questions.
So folks can feel free to unmute themselves, put things in the chat, whatever you'd like, and is easier for your communication style. While you're doing that, I can ask one that I'm curious about. In several of the other, companies and codecs and platforms and, the other material that we've been learning about, folks spend a lot of time and put a lot of emphasis on IGMP and having a querier. And, if you're connecting multiple switches together, you've got to plan that strategically. Which one is the querier so that you don't, double up or sometimes double back your data and flood your uplink and your backplane, the trunk. Does this work in a similar fashion where that's a design consideration?
Yes, and so this is no different than your 1 gig network or your dedicated IP network. Whether you're in 1 gig, 10 gig, 40 gig, 100 gig, the considerations are the same. It's just higher bandwidth. What we do at SDVoE is we have partners that are in the alliance, Netgear, NVEO, Yamaha. These are 3 switch makers that are really involved with SDVoE. And so when a customer says, gee, I really need some help laying out my network and need to understand switches and bandwidth and trunk lines, Netgear in particular, and I think Legrand also has a switch brand. We should talk about that. Luxel, yeah. And in fact, there was a conversation there about having Luxel join the party. So what we do is we take our SDV Alliance members that make switches and they jump in and they help our customers design systems. And we have a guy named Vanya. He's in Montreal where the rest of our smart people are, and he's a network person, and something basic. We can definitely help with that as well.
Cool. So I guess to build on that, then, if you're a 10 gig solution instead of a 1 gig solution, do you ever hit the wall on switch configurations and what kind of a system you lay out because you're asking 10 times more? If you have a specific quantity of inputs and outputs that would comfortably cohabitate and not redline at 1 gig each, do you find that different hardware selection and different switches in the middle are pretty critical to pay attention to when you're doing SDVoE instead?
Absolutely. I mean, that bandwidth management is super critical, and so you have to make sure that you don't exceed that bandwidth. I mentioned trunk line. I'm not a huge network guy, but you do have to be cognizant of the total bandwidth between switches if you're looking multiple switches together. And what's interesting about switch architecture, one of the first projects I did when I came along to SDVoE was looked at the total system cost of a 1 gig system versus a 10 gig system. What's interesting is you can make an SDVoE endpoint, and we have some of our partners are doing this, that are very cost effective. The ASIC, this is a little bit convoluted, but the ASIC that's the core of the SDVoE endpoint is no more expensive than a 1 gig endpoint. The A-Speed chip and the Semtech chip, they're the same price. And so you can build an endpoint that's very cost effective, and the cost of the total network, the more endpoints you have, the more heavily the cost is associated with the endpoints, not the switch. A 10 gig switch is always going to cost more than a 1 gig switch. That's just a reality. And if you need to put in a even larger bandwidth switch, there is a cost associated with that. But when we look at the total system cost of a 10 gig system versus a 1 gig system, it is not 10 times as much, right? You're getting 10 times the bandwidth for kind of an incremental cost overall.
Cool, thank you. Other folks, if you have things in the chat, looks like there's one right here. Don't understand the lack of PTP. How does SDVoE keep everything in sync?
Oh boy. Yeah, I have to apologize. This one is outside of my understanding of how to answer it, so I apologize. I can get back to you. PTP and keep in sync.
Do you know if it can cohabitate as the follow-up to that?
Yeah, I was going to say, if it's a Dante network, you're going to have PTP. So I guess it depends also on how you're doing audio.
Okay. Yeah, guys, I'm sorry. I don't know the answer to that one, but I can circle back.
Are there installs that you've seen where those do coexist? Like somebody's doing all their video through SDVoE, but they need a specific mixing board or production equipment or something else that does use Dante, and they merge and mesh and interact? Is that a design topology that you see?
Yes, absolutely. And again, used to work at a company that made some products, an audio de-embedder, and so you can do that. You can take the audio off and then just route the video through an SDVoE network if you wanted to. I also know there are several SDVoE Alliance members that are making product or in the design phase right now with SDVoE and Dante built into the same box. So absolutely, that's a thing.
Cool, thank you. Other folks with specific questions? Otherwise, I've got one more I'll sprinkle in before we close out. So a lot of the comparisons and specs side by side and tables and charts that you showed us, very few of them showed SDVoE with yellow or orange or red specs compared to the others. But of course, it's not intended to be all things to all people. What are some of the design constraints where it may not be the best choice, and you might want to look at other alternatives? Like
Sure,
you
yeah.
mentioned NDI being much less bandwidth. What other scenarios would you know that maybe we shouldn't start and lead with this?
Yeah, no, I'll just be really straightforward. We're really good in medical with SDVoE just because of the strict requirements for medical. We're talking about a surgeon who's doing an operation and, low latency, high video quality, all that stuff is super important. We win every time. However, there's an application in a hospital where you want to observe what's happening in that hospital room. You don't necessarily need to put that camera on a 10 gig network, and maybe an NDI in that situation would be better for that camera. And so there are certainly applications where, super low cost, bandwidth and latency are really not that critical. What's interesting in medical is they're watching what's happening in that not emergency room, that operating room, because they want to know when that surgery is wrapping up. They don't want to wait until the end and then send in the cleaning crew. They want that cleaning crew standing on by, as soon as that operation ends. So anyway, hospital administration is watching that emergency room. And so that would be an application where you really don't need a 10 gig. That doesn't need to be on the same 10 gig network as that image that the surgeon is looking on. So just an example, certainly there are applications where something else makes more sense.
Sure. Yeah, Ferrari doesn't make many taxi cabs.
Right.
What about encryption, information security, compliances and concerns that folks have on that front? Maybe even government applications or back in medical when there's, HIPAA and nursing labs and things like that. What might we want to know about those?
Yeah, SDVoE enables most of the popular or common security protocols. And in addition, our own USB technology, which is different than what's out there from companies like Icron and ASpeed right now. Our USB technology, which is brand new, enables encryption. So using another technology for, say, putting USB and SDVoE on a network, if you type, all those KVM things I was talking about, you type your password into that KVM using an Icron chip or an ASpeed chip. Everybody on that network can see that password. And so we've actually fixed that with SDVoE's new USB extension technology. So yes, we're going right after those secure locations with this.
I took note that you called out non-blocking USB topology as well.
Yes.
Hey, Bill, you got a question?
Yeah, I'm not sure how to ask this. So if it doesn't really make sense, I'm wondering if this is requiring a parallel network to implement. In other words, if we go into a building that has existing Ethernet cable infrastructure, this isn't something that we can just ride on that infrastructure because of the bandwidth requirements. So we'd have to literally put in a parallel structure. Is that true, or am I confused?
No, you're not. So in theory, given enough bandwidth on that existing network, you could just put this right over it. In reality, you've got a battle with the IT department, right? And they've got their network already put in and their bandwidth allocated. And when you come in and say, I need 10 gig to all of these places, that's gonna blow their mind. And so an IP network is an IP network. So again, in theory, this should just go right over it. But in practice, people aren't sharing. The data network and the AV networks are being pretty much kept separate at this point. Again, we see kind of a convergence in the future, but for the time being, they're separate networks.
But you could link them with a 1 gig link between the 10 gig switch and the 1 gig to be able to still communicate with the devices. You wouldn't be able to get video, but you could still communicate with them. You could still manage them. You could still, get that single pane of glass management of all your systems through that technology. And actually, I prefer that method for any AV over IP because, it's really bad when IT puts out a policy across the entire network that hits an AV switch that then disables Dante or disables AV over IP. If you have an AV switch that the AV department is responsible for and then connects to IT, then they're responsible for the AV technology that's going into that switch. I still think that's best practice.
Okay. All right.
More their constraint than ours.
I appreciate it.
Absolutely. Any other questions before we close out here? Other intricacies of this that we haven't highlighted yet, or pretty comprehensive and everybody's doing all right? Awesome. Well, Martin, thank you very much. Glad that you got a chance to meet us. If nobody gave you the ETC, who we are, it's a collaboration of higher ed technologists from around the country and actually with international connections. But we've got a unique partnership where end users and manufacturers are equal parties. So even up to the level of our board, we have corporate members as well as institutional members, and it's a pretty good synergy. We cohabitate well, and it's been great community for many years. So
in other words, you should be joining.
Yeah, I hit him up on that a couple weeks ago and sent him the information to join.
Yes, I have applied for what was it, Steve? It's a topic at the national meeting in the fall. I've applied for that, and this was the first introduction to this group, and I'm going to take back to my management that we absolutely should join. And it sounds like a fantastic group, so I look forward to it.
Cool. Well, it's great to hear. Thank you again for joining us and your time. Great information. Nice to meet you, and maybe we'll see you at NC State in October.
Okay, I hope so. I got my fingers crossed.
Cool. For everybody else, next session will be in 3 weeks. We're debating on the final day because Juneteenth falls that week, and also folks are recovering the week after InfoComm. But we're going to try and bring you a session on Dante. So stay tuned for that. Watch for invites in your email, and we'll catch you online the next time. Thanks, everybody.
Thank you. Bye-bye.